Good afternoon everyone, my name is FelipeGilBernal and today I'll present you this research that has been called Genesis of the Optigenic Deposits Associated with Coal Seep Sites in Guaymas Basin, Gulf of California, Mexico. Guaymas Basin is located in the central part of the Gulf of California. In this region, hydrothermal activity generates fluids at different temperatures, affecting a thick layer of organic-rich sediments involved in the formation of different seeping systems on the sea floor. In such systems, complex chemical and biological processes controlled by redox conditions, microbial activity, and characteristics and temperature of the fluids allow the formation of optigenic mineral deposits. So, this research is focused on the study of optigenic deposits from active methane venting sites in the seafloor, and its objectives are to determine paleoenvironmental conditions related to the precipitation of these deposits and to understand their origin and evolution using different analytical techniques. The samples were obtained through Alvin submarine during the expedition 3706. This submarine allowed to obtain large optigenic fragments, which is very unusual due to the technological challenges that come with a submarine expedition. To reach the proposed objectives were used different petrographic, geochemical, and mineral chemistry techniques, such as petrography, stable isotopes, X-ray diffraction, scanning electron microscopy, electron microprobe, TOG, and rock-eval pyrolysis. Through petrographic and scanning electron microscopic techniques was defined that optigenic deposits can be divided in three groups: rich in silica, aragonite-dominated, and rich in barite. These deposits have wakestone to greenstone textures with skeletal grains, like diatoms, plantic foraminifera, and pellets, minerals like gold, pyrite, and plagioclase, and a TOG content between 0.4 and 7.2%. Rock-eval pyrolysis determined that organic matter present in deposits rich in silica and barite is related to type 2 and type 3 corrosion. 87 strontium, 86 strontium values for deposits rich in barite are related to hydrothermal fluid from Southern Reef Guaymas Basin, and these values for deposits aragonite-dominated are related to modern seawater. Delta 13 carbon versus delta 18 oxygen values for deposits aragonite-dominated and rich in silica indicate that formation of aragonite cement and biogenic shells was controlled by anaerobic oxidation of methane and bacterial sulfate reduction. Delta 18 oxygen versus delta 34 sulfur values for deposits rich in silica and barite are related with tooth fields, marine barite, and hydrothermal barite. Delta 34 sulfur values for our three type of deposits show an isotopic fractionation of plus 47.6 per mil, indicating that the origin of barites and parites in these deposits was affected by microbial processes. With the collected information, we can define 4 stages of formation for coal seeps of Guaymas Basin. In the first stage, there was defined the deposition of a biosiliceous ooze with abundant diatoms and rich in marine organic matter. Later, variable seafloor methane advention induced pH changes in the system and causing dissolution reprecipitation of silica and carbonate. Then, a slightly modified seawater caused the formation of aragonite cement in primary and secondary pores. Finally, a slightly modified seawater and bacterial sulfate reduction favored the precipitation of barite and pyrite. Then, from the spaces of the Gulf of California, from the coal seeps of the Guaymas Basin, and from the stages of formation of these deposits, thank you very much for attending this presentation.